Working Cows Podcast, episode 184.
Welcome to the podcast that gives producers a platform to discuss and share paradigm-challenging practices. Practices that have increased the effectiveness of their operation and the joy that their families have received from this lifestyle.
Howdy, everybody. It's Clay Connery, host of the Working Cows Podcast, here with another episode for you guys, powered by the Global Ag Network. Very excited to be joined today by Mike Seeley and Mallory Embree from Native Microbials. They are a company seeking to produce products that can positively influence rumen microbiome functioning, and so kind of right in the wheelhouse of the Working Cows Podcast as far as producing products that can help to improve the performance and function of the critters that we are managing. So really excited to talk to them today. Looking forward to this conversation. Mike, Mallory, thanks for joining me today on the Working Cows Podcast.
Thanks for having us.
Yeah, it's great to be here.
So I'm pretty fresh as far as your organization and what you guys are doing. Native Microbials, what is it all about?
Yeah, so we hope to be the bridge, providing livestock producers, pet owners, the bridge between their animals and the best of microbiology. That's kind of really what we're about, is just studying the microbial communities that inhabit and influence animals so that we can deliver back to those animals and those that care for them microbes that impart the most beneficial outcomes to ultimately drive improvements in livestock productivity, efficiency, and sustainability. There's a lot of talk on your podcast, kind of indirectly or directly, on the topic of microbes. I've listened to some of your podcasts, and I've heard people, like, paraphrasing here, talk about like microbial excavation in the context of crop rotation or acreage resting, or in some ways, I've heard people kind of allude to this idea that we need livestock and crops on a farm together to sort of complete the carbon cycle. And our opinion is that a big problem in animal health and nutrition today is that microbiology is not leveraged enough. Our goal is sort of bring that capability to animals.
Very good.
And to do that. Sorry. Go ahead.
Yeah, that was kind of where I was headed. A next question would be, so how are you delivering? I guess maybe the first question, the better question to start with would be, how are you determining what each species of animal needs, and even variation with the species, say between a dairy and a beef cow. How are you determining what their needs are, and then we can get into how you're delivering it, I guess.
Yeah, Mal, we do a lot of microbial genomics, sequencing, a lot of advanced bioinformatics methods to decipher what's happening, for instance, in the rumen of a cow, to sort of piece together what's happening in that rumen microbiome, what's happening in that rumen ecology, what organisms are there, what biochemistries are they participating in, how does that, each member in that microbial communities, what's their function? And then off of these sort of microbial data sets, we're able to get a pretty good view as to, what organisms might be really helpful. For instance, at busting open cellulose or hemicellulose, or producing acetate, butyrate, or like in the case of beef feedlot cows, we sometimes unlock very novel biochemistries that are happening that aren't really known in the animal sciences today. And ultimately, all this capability, this sort of technology discovery capability, allows our microbial product developers to then isolate, manufacture, and deliver back to producers, pet owners, microbes that are effective, as opposed to what we see a lot of, which is, repurposed bread yeast, right? Or like lactobacillus, which is certainly helpful, I guess, if you're making yogurt, but it's very unlikely to be able to impart any environmental changes on a community as complicated and as violent as the rumen microbiome. So I don't know, Mal's maybe you could do a much better service to the hardcore science given your technical background.
You did a nice job, but I think just to add on a little bit more to that, just more concretely, what we end up doing is a lot of de novo discovery, right? So when we decided that we wanted to develop a new microbial product for dairy cows, the first thing that we did was we went out and started to survey the rumen content of dairy cattle that live all over the United States, right? We tried to capture different breeds. So we were taking samples from Jerseys and Holsteins. We were taking samples from cows in California who have a very different diet than cows that are in the Midwest, just to look at diet variation. And just we wanted to get a really broad, comprehensive view of what the microbiome looked like under all of these conditions. And just to even take another step back, the underlying hypothesis that's really driving everything that we're doing is basically, despite all these advances in animal breeding, right, over the past couple hundred years, where people have basically bred cows over and over to get a more productive animal, right? Essentially, this has led to a very homogeneous genetic background, right? So pretty much every single cow has the same genetics. These days, they pretty much eat the same food. They're managed in very, very similar ways. And despite trying to make it as even and similar as possible, we still see a lot of variation in production. And so we believe that this variability is due to, in part, the microbiome. So specifically the microbes that actually inhabit the rumen.
Well, I mean, just think about the genetics, right? Like the cow has there's like 22,000 bovine genes. There's like 4 to 5 million rumen microbe genes. Like the cow, from a genetic standpoint, like a cow to us is just skin that a bunch of rumen microbes wear to absorb what they're respiring, right? Like a cow is almost incidental, right? Like a lot of what's happening to a cow, or like what's the energy that's coming off of that cow that we use in whatever form, whether it be protein or hides or whatever, that's directly a consequence of the rumen microbiome. Like if you sterilize a rumen, there'd be no cows ever anywhere. And so, I mean, a lot of what a cow is, right, is microbial in the rumen. And like, think of a grazing cow, right? Like how much energy is lost out the backside of the cow? 80%, 70%, I don't know. Some large amount of energy has gone out the back end, right? We kind of asked ourselves like, well, what if you could capture more of that energy, kind of partition that carbon and electron flow back into the animal, right? What if you could take that energy lost, 80% or whatever, to 50% or 40% by improving that rumen engine? That's kind of what we're all about, is working on that piece there.
Kind of leveraging the natural variability that we see, right? Figuring out why the more productive animals are more productive.
Yeah. So, could we maybe before we dive in any deeper, maybe a good kind of baseline would be to talk a little bit about rumen function and how it works, and how we get into tweaking those things. So maybe we should understand how it works first.
Sure. So maybe let's start on the microbe side. Yeah. And then maybe we can get more specific into dairy cows and beef cattle. So if you look at microbial communities, right, there are these very, very complex networks comprised of thousands upon thousands of different microbial species, right? And when we say microbes, we're talking about bacteria, fungi, viruses, protists, right? All of these different microscopic organisms that actually live in these environments. And I guess although we typically think of these microbes as kind of like lone rangers, right? Like we think about like the lone pathogen or the lone lactobacillus, they actually are very, very social. And so they form these networks where they actually work together Part of this is due to the fact that these organisms tend to have smaller genomes, just because it's more energetically efficient, right? And so because they have smaller genomes, they don't encode necessarily all the pathways that are required for life, and thus they have to work together. And so basically, I guess what we're trying to do is figure out what microbes are important from like a biochemical perspective. So which ones are actually generating important molecules for the animal that actually make them more productive. But secondarily, we're also looking for microbes that are highly connected and communicative within this network, right? Because that's essentially what allows them to influence a broader part of the community.
Sure.
Yeah, like think about like the example of like neocalamastics, right? Like what? Like think of so rumen fungi, these filamentous fungi are really good at degrading these really resistant feedstuffs. So, all that energy that's trapped in that silage or that forage, like the fungi, like a lot of these things are able to attach themselves to the surface of the plant, pop a little hole, and then they shoot their hyphae in, which are like these tentacles kind of, and then they shoot spores out of themselves into the plant. So they're kind of like, it's like hydraulically fracturing a plant for any of your energy listeners, right? It's kind of like, kind of what they're doing. They're like biological, alfalfa, hydraulic fracturing via rumen fungi. Like there's these communities of things that are kind of participating in different steps in that ecosystem, kind of ultimately with the aim of like liberating and getting access to the glucose and stuff that's in the feed so that they can grow, that they can live. And then, this complex ecosystem, when you fully map it out, then allows us as microbial product developers to then make more intelligent decisions as to which ones you should give back to the animal, to then impart kind of back to that idea of getting more energy into the animal, not out the backside of the animal, so that cow can have more energy to thrive, however he or she needs it. Could be for milk production, could be for health, could be for whatever.
Because ultimately, the rumen microbial community consists of tens of thousands of organisms, but obviously we can't create a product that consists of tens of thousands of organisms. So you have to be very smart and deliberate about which ones that you pick, because you essentially want to select the organisms that are going to have the most influence over the network.
Anabolism. Sorry, go ahead.
Well, yeah, I was just going to say I'm kind of committed to asking some dumb questions here today. So, if I understand what you're saying correctly, it sounds like you're trying to find those organisms that are kind of the leaders of the pack, and they are the ones that are going to kind of give the biggest bang for your buck when you influence them positively. Is that kind of accurate?
Exactly.
Right. Because from our survey experiments that we did initially, where we screened hundreds upon hundreds of cows, we essentially identified what a good microbiome looks like, right? We figured out what microbes live in the most productive animals. And so the goal of our products is to make all of the animals look like that most productive cow.
Is that most productive cow generally just the one with the most efficient rumen? And another maybe tweak of the perspective that I'm wondering about is, do more efficient rumens take the same amount of nutrients in and process them more efficiently? Or another way to say it is, can the same frame size cow eat less and get more out of it than maybe her sister cow who's the same frame size, but she's less efficient from a rumen perspective, and so she's eating more and not getting as much out of it than someone else in the herd?
Yeah, we're finding that more efficient cows have a microbiome that allows them to digest the feed more efficiently. So they're just getting more energy out of the same feed.
So does that necessarily change the composition of what's coming out the back end? And the reason I asked that is I just sat on a webinar last night where somebody said that they were doing the math on if you feed low quality hay, where a lot of it gets wasted, and maybe more of the issue here is wasted hay than it is actually what's coming out of the back of the cow. But they figured the nutrients that you were leaving on the ground were worth about $60 per ton. And that's positive that they're adding about $60 per ton of nutrients back onto the soil, and we're trying to influence those soil microbiome. We're trying to influence that positively too with our management. So maybe actually sometimes more stuff coming out of the back of that cow is okay, as long as we're being intentional with where it gets placed and some of those things.
Yeah, I mean, some of our customers have cited, in dairy specifically, improvements out the back end. I mean, it's not empirical, right? It's not like I can tell you the chemistry profile over time, right? Or like, I don't know how much nitrogen or something like that. And we've never looked at that. But consistency of manure has been something that in our dairy work and our dairy customers, some of them have cited that as something that they've noticed pretty quickly. From a truly chemistry standpoint, we don't have enough data to substantiate any claims there.
Sure.
But I mean, if you think about it too, like take Posilac, right, which was a dairy specific product, right? You would every couple of weeks you would provide them with this hormone, and essentially what it would do is it would trigger sort of an overexpression of that hormone biology, right? That there was a positive, I guess, in the sense that more milk was being generated by that animal, but all that energy that was being directed towards milk production was effectively energy that was being stripped off the animal's back, right? So 250 days of Posilac treatment later, the cows were pretty depleted, were skin and bones. A lot of the animals, you had to be culled because it was hard to inseminate a dairy cow that was skin and bones, and so by kind of working with the existing biology, I think, and given that so much energy is not partitioned intelligently into the animal or being lost completely, having more energy could have a lot of positive benefits if it's partitioned correctly. And so that's kind of, I think from a microbiology standpoint, a lot of what we see is really, it's just, there's a lot of positive health consequences that we hear from our customers that result as a consequence of just having a better rumen fermentation profile.
Yeah, absolutely. I think it kind of goes back to that idea of we were talking about mining the soil microbes. Well, you can also mine the energy out of that cow to the point that she can't perform anymore. And if we're, rather than doing that, we want to increase rumen efficiency, rumen function. So yeah, let's talk a little bit about that. How are you guys doing that, or what kind of approach are you taking to doing that? What are some of the products that and we're talking mostly to dairy or to beef producers here on the Working Cows podcast. So maybe tailor it a little bit towards them, but how are you guys approaching impacting those rumen microbiomes positively in those beef animals through your work and through your products?
Oh man, we could be here for hours talking about the beef feedlot rumen microbiome. I mean,
where do you want to start? Because
I'll start with the whole lactic acid thing, and then I'll let you.
Sure.
Then I'll let you put the hammer down. I think the general perspective in the beef, we've really only done work in beef feedlot environments. So specifically studying the rumen microbial community on a high grain diet. In the conventional dogmas in animal sciences kind of state that, when you give a cow a lot of corn, right, the lactic acid builds up, the pH drops, and the animal crashes out, right? Obviously acidosis, but you could see other consequences like liver abscesses, increased incidence of bovine respiratory disease, whatever. But the fundamental scientific dogma is that a lot of corn causes lactic acid to go up, which then causes these problems. When we studied the when we did the full sequencing of the rumen on a high grain diet, and then we were linking the distributions of microbes to the metadata, like, to the, could be qualitative, like high performing or low performing cow with a high feed efficiency versus a cow with a low feed efficiency, or it could have been more quantitative, like the amount of acetate or VFAs or the pH or something. When we went through that full survey to decode the beef steer on corn rumen microbiome, and we put it through our technology platform, a lot of the organisms that our technology platform were saying that was telling us that were important, we looked at the organisms themselves and we looked at their metabolism, like what they're capable of doing. None of them had any genes really encoded for lactic acid utilization.
And that's what we were expecting, right? Just because everybody we had talked to said that lactate was the main reason why acidosis happens, right?
Yeah, and so it was kind of like, we're like, okay, either we're very wrong and we're not very good at computer programming and genomics, which I think was not very likely because we have very talented people here. Or there was a piece of the puzzle that was missing. Yeah, and so what we found is that there's actually some very different drivers in the beef feedlot world that's causing a lot of these problems. It has very little to do with lactic acid accumulation.
I mean, we have a good hypothesis, I think, about other things that might be happening in this situation. And I think just to build a little bit more on what Mike was saying, again, we were measuring all these parameters about the animal, right? We were looking at lactate concentrations as well as VFA concentrations within the rumen. And it turned out that the highest performing steers actually had really high concentrations of both of these molecules. So that was kind of a huge red flag for us too. So we went back into our data, we started looking into literature, and I guess we essentially have this hypothesis where you take a steer, right? You start adapting it to this high grain diet, and basically fermentation just goes completely crazy in the rumen. The microbes have readily digest any sort of simple carbohydrate that you give them, and so their population just explodes. Instead of an accumulation of lactate, though, we actually think that there's an accumulation of carbon dioxide, which is actually a very common microbial fermentation byproduct. And of course, this molecule is also important too because it's involved in pH buffering, right? So generally, your rumen pH is buffered by bicarb. You actually put it in feed to try and supplement this buffering effect. And so as carbon dioxide builds up from all this microbial fermentation, it actually can go into solution and act like an acid. And so when this happens, it basically destroys the buffering ability of bicarb within the rumen, which might be why we see this severe pH decline during acidosis. As we started to dig into this more, I guess more pieces kind of started to fall into place because carbon dioxide can, of course, diffuse through the epithelial lining of the rumen as well, the blood. And so it could explain some of the other systemic effects that you actually see in acidotic animals.
Interesting. And so how do you guys approach that? What's different about what you guys are doing to make that to bring that relationship back into balance or to help things function as they should?
Sure. So I guess the accumulation of CO2 is kind of the first step that we see in the progression of acidosis, right? So from there, of course, you still have all of these microbes that are making a bunch of acids, right? VFAs, lactate that also drive down the pH. We actually see the microbes switch over to solvenogenesis as well. So instead of making acids, once the pH gets low enough, they actually start making solvents like ethanol and butanol, for example. And so it's kind of like the first half of the cycle, right? The part that's really driving down pH. And so to bring it back, we're seeing two processes emerge within the microbiome. It's acetogenesis and methanogenesis, right? I think to maybe explain a little bit more about those two, I think methanogenesis is the one most people are familiar with, right? It's mediated by the methanogenic populations within the rumen. They like to take carbon dioxide, hydrogen, and convert it into methane. Acetogenesis, people might not necessarily be as familiar with this one. Essentially, it takes the same byproducts, so carbon dioxide, hydrogen, but it uses the Wood-Elgin-Dahl pathway to actually convert it into acetate. And so where we're seeing our microorganisms fit in is there's actually 3 in the product that we're looking at primarily, and they all kind of have different function. The first one really attacks the carbon dioxide. It can utilize that initial burst of carbon dioxide from the over-fermentation and try and stabilize the decline in pH a little bit more. This particular organism uses the CO2 along with glucose to make succinate, which is a precursor for propionate as well, which is another important molecule for steers and growth. The other 2 microbes are involved in the other aspect of the cycle, so the solvenogenesis as well as the acetogenesis, to try and take some of those intermediates and actually turn them into molecules that are more valuable for the steer than methane.
So are you, in a perfect scenario, are you seeking to speed up the process of switching over to a higher corn diet? Are you seeking to maybe not change the speed of that process, but just remove some of the risk that is involved with that process of switching that rumen function over through your products? What's the goal that you guys are shooting for?
So when the cattle are on the step-up diet, it actually creates a huge dysbiosis in the rumen, right? It gets very, very turbulent. And actually, the only thing that comes close to what I see in the rumen of a steer stepping up is the microbiomes of humans who have antibiotics. So it's a pretty severe change. And so what I see our microbes doing is helping stabilize and direct that process so that even though it's turbulent, the microbiome still ends up in the more efficient state rather than one that's less efficient. So it's not necessarily speeding up the step up. It's just making it more efficient and I guess making sure it ends up in the right place.
Just to clarify, maybe they are getting to a point where they're converting a higher percentage earlier. Would that be accurate?
I would say it's more like you're shifting the microbiome to be able to process that grain much more effectively without the deleterious health consequences.
Sure. So it is kind of removing that risk of, maybe we're widening the bell curve of the animals that might fail that test, and failure is kind of dangerous. Is that good?
Right. So basically, the thing that could happen is CO2 accumulating too fast, right? Because that's really what's driving the pH down. And so anything you can do to kind of slow that down and make it so the animal can adapt better, right, will just improve the health of the animal.
Yeah, and the product itself the product itself we provide. It's a daily. You add it to the ration every day throughout that 180 days or whatever.
Right.
It's not like used for the first 30 or something like that. It's something you got to use the whole time. And again, it's about really shifting the distribution of those rumens that are being treated with these native effective rumen microbes to obtain a state that allows them to be more effective processors of that diet. Overall, we see very positive outcomes in the classic kind of economic drivers in the trials that we've done.
Sure.
And we're hoping to see, we're doing a big trial coming up here at a university. We've done lots already, like lots and lots of cows, but we're doing a specific one targeting methane to look at, like we already have a sense for, by doing this, you see improvements in the feed efficiency, kind of value related stuff. But we're very curious to see if you're able to partition or shift the distribution of the organisms this way by feeding these types of microbes. Do you end up with possibly cows that are producing less methane? And so we're doing a trial where we have a grow safe system and all that. We'll be able to quantify that by this summer.
do you guys have you done anything or focused at all on the grazing animal, or has it mostly been up to this point the focus has been on the feedlot side?
Now, I think we should talk about how the diet influences the distribution of organisms. I think it'd be kind of cool for the audience.
Sure. So, yeah, diet definitely has the biggest impact on the rumen microbial community. So if you look at something like a grass-based diet versus a feedlot diet, right, they're obviously very, very different. So one of the reasons why we think that the feedlot rumen is more tailored towards like the solvenogenesis, for example, is because there isn't as much cellulose in the diet. Mm-hmm. We found in our dairy cow survey that if you loosely break up the microbiome into cellulolytic versus amylolytic organisms, they actually oscillate around each other, right? Just because there's a lot of grass in the diet. And so when that happens, those fungi that Mike was describing, they start growing like crazy. They shoot out enzymes. They break down grass and liberate more glucose that then allows the amylolytic populations to shift up. So that said, I guess to get at your question more directly, so we haven't studied beef cattle in a grazing situation directly, but I have a feeling that all the work that we've done with dairy cattle actually applies almost directly. So in the case of dairy, we're looking at microorganisms that help break down all of the different grasses and make the feed more digestible. I think we could feed those same microbes to grazing beef cattle and see a similar effect. Just enhanced digestibility of the grass that they're actually consuming.
Sure. What kind of intake are you needing per day per animal to make the product perform as you want?
I mean, we only really market in ruminants currently to dairy producers, and we provide them to customers at around 5 grams per cow per day. And so I think what's important to point out here is that, it's the volume isn't a lot, but the metabolism of the microbe is what matters. So there's like kind of 2 driving forces, right? To why this works. I think one is premised on the notion that like things are where they are because they've evolved to be there, right? Like you should, if you're going to use a microbe to influence the rumen, you should use a rumen microbe. They're there for a reason. So like, why would you use Saccharomyces or something that's not evolved to proliferate in that ecosystem? It's like, Clay, if you had like a mouse problem in your house, like I guess you could use like a tiger, but there's, it's unlikely that the mouse problem will go away, and you'll probably create some other issues potentially. And so the similar kind of like working with the ecology principle, like, I think there's that kind of basic thing to keep in mind as to why this works. The second piece is that, microbes have like 2, they want to live. They want to survive. They have 2 strategies for survival, broad biological strategies. There's the things that are really good at taking energy and storing it, or taking energy and copying themselves. Those are things that are anabolic, right? And that's one strategy of survival in microbiology. Is the organism can take energy and it can store it to live, or it can copy itself to live. And then the second strategy is catabolism, where they take energy, but rather than whatever they're getting, rather than copying themselves or duplicating themselves or just storing that energy, they're able to carve out a really interesting niche in the community by, for instance, in the rumen, breaking something down. It creates a dependency on the community, on that organism. And a lot of the things we're interested in are catabolic, right? So if we took a handful of rumen content, it was like we sequenced it and then we plotted it on a curve to just show the abundance of each organism in that handful of rumen content. It's a skewed distribution. That plot is called the rank abundance plot. What you'll see is that there'll be a few things that are very abundant. It's like the weeds, right? The weeds of the microbiome. And then there's a tail of things that go on for a long time. And the things that are in that tail are typically the things that are engaged in catabolic processes. And so, yeah, I think it's 5 grams per day. And the benefit is that you're giving organisms that are able to persist in that ecosystem and are engaged in highly catabolic processes. Processes that give them an advantage from a biochemistry standpoint, unrelated to just growing. And so from our standpoint, like it creates a layer of challenges for us, right? Because from a product development standpoint, like all the things we are really interested in are not very abundant in the environment, right? They're not like just doubling like crazy, like a weed. And they're physiologically, they're tough to manage. They're anaerobic. They often do not sporulate, right? They want to be in the rumen and the rumen only. And so how one goes about manufacturing them so that a customer or a farmer or a pet owner can use them without having to spoon feed a bunch of microbes to each cow individually is a challenge. It's something that we have been lucky to have worked with smart people on and sort of solve that sort of riddle. But yeah, and so I don't know. That was probably
I know I like it.
Wordy.
It's good.
Yeah.
So currently, what's available, and then kind of a timeline for other product rollouts, and where are you guys at as a company?
Oh yeah, sure. We currently, we have our dairy product Galaxis, which is made of rumen microbes for dairy cows. That's available in California and certain parts of the Midwest currently. By the end of this year, next year, should be national. We actually have a second generation dairy product as well that's coming that will be really cool. And that should be available later this year. On the beef side, our beef feedlot product is still in development. Back to this this sort of harsh reality that we face. The organism's physiology requires a lot of kind of engineering to establish, to be able to give to customers that they don't have to spoon feed and keep it in a refrigerator and all kinds of stuff. So that one's still in development. We should be bringing that to market sort of early next year, that time frame, maybe February, March of 2022.
Yeah. How does the product come? How is it delivered to the animal? Yeah,
it's just it comes in these like 10 or 20 kilo Mylar bags. It's vacuum sealed, and the number of head you have on your operation will dictate whether you use a 10 or 20 kilo bag. And just open it. In dairy, you just add it to the mixing wagon, probably similar in beef, and you've got 5 days stability in feed, an open bag in feed, and that's it. Just gotta add it yourself like a salad dressing and mix it, and then feed, and good things will happen. Basically.
Very good. Very good.
Yeah, I think.
So
sorry,
I'm sitting here in western South Dakota. You guys are in Southern California.
Yep.
In my office,
Yep.
which I am not in right now, but in my office, I've got a little plaque hanging up of the top 5 beef producing states. I think when I started the podcast in 2017 or 2018, and I think back then number 5 was California. Well, we're Northern Great Plains folks here, and we like to think of ourselves as always among the top states producing, and so we tend to ignore California's beef production, but they are a legitimate powerhouse in the beef producing sector, and that's a long way around to saying it might be more obvious than I think it is. But how did you guys get into doing what you're doing with rumen function and supplementation and microbials and those things?
That's cool. Yeah, no, yeah. The Imperial Valley, right, is a couple hours from us. Like just dead east of San Diego. There's a ton of feedlots. maybe Mal, maybe you could give him a bit on your background and then how we met. And I can.
Yeah, so I guess at a high level, we're both microbe people. Neither of us are animal people initially. So I actually have a PhD in bioengineering where I studied microbial communities. So I was just interested in just the complex microbes that live everywhere around us in the environment, right? So I was studying microbes that lived in wastewater digesters, in the natural environment, in microbiomes in mice, actually, in context of human health. So my thing is just understanding these communities and how they actually assemble and work together. And I guess I ended up meeting Mike because he's also kind of from that world.
No, I mean, I'm just a lowly entrepreneur. You actually make stuff. I just talk too much. So she's super hardcore scientist, and I'm just an entrepreneur. I've been involved in microbiology stuff, like deep science, trying to build cool new products with microbes for about 10 years. I worked at a company that was really focused on soil microbes previously. Looking at the endosphere and the rhizosphere of plants like corn, soybean, to try to code that microbial relationship between the plant, the soil, and the microbes, to try to do something, different technology and approach, but similar vein of finding cool microbes to use as a fertilizer, as a pesticide or something. When that company had run its course, we got acquired by DuPont Pioneer. Mm-hmm. One of the Silicon Valley VC venture capital supporters of that company asked me to work there to help incubate and start a couple of things. And so this was one of the things that I got really interested in. Was, I had spent a fair amount of time looking at like what industries, it was like what industries currently use microbes as products, and then like drawing a map of that, and then saying, well, what are the microbes that are used? And I to be candid with you and your audience, I grew up in like the New York City area, like I didn't know what a cow was. An animal to me was like a subway rat, it's like, it was a different, I didn't grow up in it, but I've always been really interested in, working with really smart people to try to do some cool stuff that's new. And I stumbled into the animal industry. I was talking to my mom the other day. She still doesn't know what I do. And if you were to ask her, if I asked my mom, like, Mom, I did this. I was like, she was getting out of the subway. She's a travel agent in Midtown. I was like, what does a farmer look like to you? And she painted a picture of somebody that's like invariably associated with plants. Right. And the reality is that most of agriculture from an economic value standpoint is not plants, it's animals. Right. Like corn, soybean is basically useless to us without the transformers, the animal themselves that can take that junk and make it into something good for us. And there's this general societal, I don't know, like a fog or something that people don't quite understand what it is. And I was sort of similar. Like I didn't really think about livestock agriculture. It's pretty alien to me. And I stumbled into the animal microbial space simply because I was trying to find industries that could use better microbes, because that's what I like to work on. Work with smart people like Mallory, and let's go find some really cool microbes that can actually create value for customers. And I stumbled into the animal market where they're using microbes, and I just like kind of laughed because I was like, what? They're feeding Saccharomyces to cows? Like, I don't know. It seems kind of funny. Like Saccharomyces, like I know it's useful in a bowl of flour and water and a little bit of salt, but it's not a rumen microbe. And it just seemed like there wasn't a lot of advanced technologies from a microbiology standpoint. And so that was kind of where, we kind of got together and the kind of light bulb went off. And we said, hey, maybe we should build some really cool microbial products for livestock producers. and pets. Based on this comprehensive assessment of what goes on in the animal, like really investing the time and the energy to really understand it and guide the product development so that customers can be more successful. So that was it. We kind of got together 5 or 6 years ago and we set out on this journey, and it's been pretty cool.
I've got a secret Facebook group that I solicit questions from, and I've since I've got new equipment, I've taken to having them call in and leave voicemails with their questions, and then I play them live on the show for guests and let them answer them. And so the name of the secret Facebook group, kind of a point of connection, is the Working Cows Microbiome. So that kind of we're on the same page. We're all recognizing that we as humans, them as bovine critters, they're actually more microbial community than they are actual animal. I think you alluded to that earlier. 22,000 genes in the genome of the cow, and I think you said 40 or 50 million in the microbiome, or in the rumen. 4 to 5 million. Yeah. So I mean, it's a big, yeah. And we've all heard that, you're actually more bacteria than you are you. So, but yeah. So anyways, I think we're on the same page here as far as starting to look at what's really driving performance from the animal's perspective. And I did get one voicemail left before we started. So if you guys got a minute, I'll play that and let you take a crack at answering the question. Sure. If you can't hear it, just wave at me.
Sounds good.
So far, we've had good success.
Hi, Clay. Mal Peterson. Just responding to your question about rumen function supplements, etc. My question is, there's two different parts to it. One, we've gone away from bulk supplements as far as like barrels, flick tubs, things like that, and we've gone to a custom mix in a block. The question we're having is, what part of protein actually turns carbohydrates into energy? So if it's a 20% block, the forage we have is highly lignified. It's 4% dormant forage. What percent of that's actually going to turn into energy, and how much fat or immediate energy should we include in our supplement? These are second and third trimester cows in winter grazing scenario. And then my other question has to do with ash. Is it just a filler? I'm not sure why I see a lot more of these pressed blocks with a lot of ash in them, somewhere in that 20 to 30% range. Just wondering, we see a lot of different variables between block brands and who's making them, how they're making them. So I just wondered if that's a point of concern, if it's a moot point, or what the opinion is on that. Thank you, sir.
There's the question from Mal. For Mallory, maybe, I don't know. But
so I don't necessarily know how to answer the first part because I'm not a nutritionist, right? I'm a microbiologist at the end of the day. But the ash one kind of seems funny to me. From what I understand, it's mostly just rock, right? It's some sort of calcium with maybe some elements within it, right? So I don't know why they would feed more of that, right? It's not necessarily something that's going to be a huge source of nutrition for the microbes anyways. It's not something that they're readily going to ferment.
So maybe, like he said, maybe it is partly a filler. It's not hurting anything. So they're and it might be cheap. So they're putting that in there as a filler, but we don't.
That would be my gut feeling.
Yeah. Gut feeling.
That would be my gut feeling about it. There you go.
Sure. So I think we've given people a taste today, a sample. But any major nuggets that we left on the table? Anything that we haven't covered today that you were hoping we would get around to?
In general, I think people should be really optimistic, right? Like our view is that livestock producers are have not really been given a lot of new tools, from the technology providers, the input providers. And I think, that people should be optimistic out there. I think these advancements that are happening in sequencing, kind of like what we're trying to take advantage of, but other folks are as well. I think there is a new dawn coming for animal health and nutrition, for ruminants and monogastrics as well. I think, and a lot of these new solutions are going to be not only good for their bottom line, but also very good for the overall ecology that's going on. And a lot of these solutions that are going to be biological, again, as a consequence of humans' ability to now interrogate biology much more effectively because of sequencing. A lot of these solutions are going to work in harmony with animals a lot more elegantly. And so I think the only thing I'd like to just highlight is there's a lot of good things that are coming for the industry, and a lot of them are coming pretty soon. And so, specifically as it relates to microbes, that's our like narrow sandbox. But I think there's a lot to be positive about. I think there's a lot of good things coming because of our ability to really interrogate biology in a much better way than we ever could before, right? Like, I mean, a lot of what's used today, where a microbe is a product today, that's not necessarily because the providers of those technologies don't want to provide cool products. Of course they do. Of course, like you don't want to most people aren't in the business of selling snake oil, right? Like most people, my view is they want to do good things, and build cool stuff and do good for the world. But what we have today is kind of a function of the technology and the tools that were available at the time. And there's been a lot of changes, a lot of advancements. The ability to sequence a genome 10 years ago, to do what we did would have cost us the entire annual GDP of Earth, right? And now we can do it for a tiny fraction of that because of these advancements in the genomics tools, data science. You had this convergence of two big events, right? From a technology standpoint, you had a very, very fast reduction in sequencing costs, right? Where the cost to sequence just a base pair of DNA has gone from $10,000 to whatever, $1 in a year, in 10 years. And then the ability to analyze these data sets because of Moore's law, right, has gone up and continues to go up exponentially. And so I think, livestock producers, folks that care for animals and cows, there's a lot of really cool tools coming their way to really help them out. It's not just from folks like us. I mean, obviously, we think we're pretty good, but there's a lot of people working on this. And so I think it's a lot of good things coming for people out there. And I think there's a lot to be positive about. And a lot of these solutions are going to be great, not just for your bottom line, but for the environment as well. First and foremost, it obviously has to have an economic value, but they're going to work in harmony with the overall ecology of what's going on. So I think it's a lot of things to be really excited about. I don't know, Mal.
No, I agree with that. There's so much that we can learn from the microbiome, right? It's so intimately linked with animal physiology that if we can use our tools just to kind of measure the state of the microbiome, it'll give us information about the animal's health, right? And the status of the animal, right? And maybe what it needs. I think it's really cool.
So kind of just one follow-up question on that you mentioned there. You mentioned earlier the methanogenesis, the production of methane by these rumen microbes. Through use of your products, are you guys willing to say that maybe that even production of methane is reduced through the use of these products?
We have some preliminary data that suggests that that's the case. As Mike kind of mentioned earlier, we're now measuring that directly with a university study that that actually just started. So we'll have more concrete data. But based on the cycling of the rumen, we think that our microbes are helping to siphon off more energy into that acetogenesis pathway, So they're essentially taking the intermediates away from methanogens.
And giving them to the animal.
Exactly. Or making acetate instead of methane.
And I don't know, is that related to, I think, is it like nitrate recycling? That, they can recycle that nitrogen or that nitrate protein. And so, yeah, I mean, there's a lot of different systems going on there that we're still trying to wrap our heads around, I think, on some level.
Yeah. So the nitrogen cycle is its own totally separate in the microbiome. Yeah. And so the one that we're focused more on is actually the carbon cycle. Right. So what happens to the glucose molecules and where do those different atoms end up?
Really appreciate you guys' time today. Where should we send people in the show notes page, links or other information that you guys would like put up there? What are some of those? What's some of that data that you want included there?
Oh, just we could just go to our website. It's just I'll type it in here, nativemicrobials.com. They can also email Mallory or myself. My email is just mike@nativemicrobials.com. And Mal is just Mallory at nativemicrobials.com. Or if you want to just email info@nativemicrobials.com, that'll work too. And there's some good information as well on our website. We try to, we're very much about like learning and communicating advancements in these areas. And so you can obtain additional information just from going to our website, just by poking around different spots there. I think could be helpful for people. But just feel free to email us whenever. Anybody out there, if you're interested in talking, we'd love to talk to you just about the science or whatever.
Yeah, sounds real good. Well, I'm excited to share this, and thank you guys again for your time today.
Thank
you so much. Thank you so much for having us.
Fascinating discussion there with Mike and Mallory of Native Microbials. I really appreciate them taking the time to join me today. Really looking forward to next week. We'll be talking with James Rogers. James is a former manager of the Wine Cup Gamble Ranch, a 1,000,000-acre ranch in Nevada. And he has gone out to do some different things and to pursue some different things. But he emailed me and got in touch with me about something that has been a burden for him in the regenerative agriculture space, and actually coincidentally, or as I would say it, providentially, also a burden for me in the regenerative agriculture space, seeing how I think there is maybe not a recognition of the beauty of God's design in the way that everything works together, being, the soil, the microbes, kind of what we were talking about here, the beauty of God's design in all of those systems that work so well together, and that God placed them there, doing the job that he had them there to do, and all of this system just kind of works so well if we will get out of the way. We talk about ranching in nature's image, ranching in sync with nature. Well, I think that's a hat tip to God and his design. And so James and I have been sharing that burden back and forth, and we decided we would sit down, press record on the conversation, and share with you a little bit of how we see the truth underneath regenerative agriculture. So it was a fascinating conversation. I look forward to sharing it with you. I would encourage you to tune in next week for episode 185 of the Working Cows podcast with James Rogers.
We invite you to visit workingcows.net to subscribe to the show via iTunes or Stitcher. You'll also find detailed show notes pages, resources from our guests, and the industry leaders who have influenced them. For more ideas on putting your cows to work for you in a more profitable way, tune in next week.